Ready? I hope so. Aloha, everybody. I'm here at the hub with Mr. John Stallman.
Aloha.
Mr. Dane Dupont.
Hello.
And we're going to give you guys an update here on what's happening with the eruption and whatever else we can include as well. How should we start it off, guys?
Take us there, Phil. What do you want to do first? Walk us through it.
Should we talk about earthquakes first?
Yeah. Okay, yeah, that was a big topic today. Yeah.
Excuse me. How's it going, Chris? Good to see you guys. Lisa, Lawrence, thanks for joining us. So we're just going to get right into it and switch the camera around and show you guys some earthquakes. I see Sarah's here also. Well, this is not the earthquake page. This is a Fissure 8 page. So, well, you guys get to see the webcam from Fissure 8. This is probably from, might be a couple hours ago now, when the light was a little better. But you guys can see there's a good amount of gas coming out of there.
One change to note on here, it might not really mean much, but we're talking about small details, so I use my finger. Oh, we got the pointers. So these gas vents way in the back of the fissure, we've seen the gas plume coming from in the back, and maybe 2 or 3 days ago we started to see more gas coming from the pit in the center. So it's kind of shifted around, but that doesn't necessarily mean there's more gas. It's just visually we can see it coming out of this pit, and it wasn't a few days ago. So.
Yeah, and that's the wrong button.
Whoop.
Oh, it's the light.
Glare inducer.
But what I was going to say is, this is totally off what I thought I was going to do, but it doesn't matter.
That's okay.
I've been spending a lot of time at the summit the last several days, a lot of this week, checking out the views, and, I've most of it I've been going early morning.
Okay.
And what I've been able to notice is that, especially the last 3 days, you see a huge amount of steam and gas producing, even forming clouds that you see, like, something about the weather the last few days has been very conducive to big plumes of gas drifting across the island, right? So, I thought it was kind of weird. This morning I was leaving my house and I driving down the highway, like it was totally sunny and clear at my house, and within a half mile I drove into a wall of, I presumed it was fog, but it could, in hindsight, maybe some fog from Kīlauea might have been coming out and blowing that direction, which is not far from where I live.
Could you smell anything?
I didn't do the windows down test. Yeah, kids in the car. Yeah, when you're kids, yeah, and can't use your kid as a SO2 meter.
No, you shouldn't.
Usually. But speaking of gas, do you want to jump in, Dane, with what you talked about?
So there's definitely been some changes in gas. It seems like there's some issues or some nuances that happen when depending on the rain and the winds. So in Leilani about 3 days ago, it was one of the worst days since the pause in terms of SO2 and bog. It was interesting in that there was multiple different, and there was 2 different smells you could catch when you were out there. There was the definite SO2 smell when you were directly over the vents, but when you were looking at it, and where you were further away, like quarter mile away, half mile away, there was definitely a mix with whiffs of something else. Since then, USGS has come out and confirmed that that is H2S. There is H2S in the lower East Rift Zone that they have detected. So that makes sense, but when it was steamed out like that 3 days ago, you couldn't even see Fissure 8 from any angle from the roads. And normally you got 3-4 angles, easy view. All of them just steam clouds. So, and there's no activity change. That's the thing, is we haven't seen anything change. And that amount of steam has to be related to something else. Has to be related to the weather, the rain, the winds. We know it's been muggy, the trade winds have been gone. I think that has a lot of play in it, a lot more than initially thought even.
Yeah, absolutely. I mean, when you live through it in person, right, it's like maybe more obvious. I don't know if that's a good way to put it, because we were looking at the signals, reading the reports, and we're like, oh, it could be this, could be that, but, it sounds like when you were out there, Dan, and experienced that yourself, seemed like you pretty well nailed it.
Yeah.
As far as like what was happening and what was going on, yeah.
Yeah, definitely. And then if you look up the sources on it, the best way to check, or the most sensitive way to check for SO2 is just your nose. And you get used to the SO2, the sulfur, when you're, earlier in the eruption, or when you're standing directly over a vent and looking into it. Yeah, it's sulfur, and you can smell it. Otherwise, it's this mix, and that's the interesting thing and the hard thing to step through. But when USGS comes out and is already saying, oh yeah, we have H2S at Kīlauea, it's pretty simple just to extend that to, all right, it's at the lower east drift zone too.
Which they did state, right?
What they just stated, and it's like, all right, cool, that makes sense. Otherwise, if that wasn't the case, I'm lost.
Right.
I don't understand what's happening.
Yeah. The H2S is kind of something we expect as the eruption's winding down, the shift in the ratio, so it's neat they record that. But the caveat to that, like, a couple days ago seems like one of the thickest, foggiest, most noticeable days we've had in a while. But we still need to see if there's any actual change in the amount of gases. They put in the report today that there was, 30 tons, less than 30 tons at the summit. And we assume it's still really low at Pu'uo'o and the lower rift, but they didn't actually measure that yet since the 11th. So hopefully when they get the next measurement in their update, it'll indicate if the gases were low the whole time or if there's been any changes.
Right.
But most of what we experience is probably the change of the weather pattern made that really thick whiteout. But we'll have to see if there's any measured change to the gas when they measure it again.
Yeah.
Right.
And usually in things like that with USGS, I've come to just expect when they've stated something and they just continue to stand by that means they detect no change. So it's not worth changing the report. So they just keep on it as long as that's the case. If it changes, then the report changes. But it's kind of a safe assumption to say as long as this report isn't changing, then it doesn't need to be updated.
Right.
Yeah.
Right. No news is good news, huh?
Yeah, no news is good news.
No update since the 11th then. 11th was the last measurement down there.
Yeah. So, all right, gas guys, I know you guys got your challenges, but we would like some more measurements.
Always good to see.
So, all right, what I was going to show you guys start off when I didn't have it quite ready was the earthquakes to start off here. So, let me look at the earthquakes map. And this is just for the last 24 hours, all magnitudes. So none of these earthquakes on this list is larger than a 2 point, well, that's right, no, there's a 2.4, apart from one notable one that just happened earlier this morning up by the north tip of the island over here, which is been put as a 4.0. Let's tap that one and give you guys that info. My fat finger in there.
Maybe tap it.
There we go. So 4.0, 11 kilometers southeast of Kapa'au. Oh, excuse me, guys. Something caught in my throat. So that one was at 20 kilometers down, right? So that's, I can do the math in my head, maybe 13 miles, somewhere in that range, yeah. Fairly deep, and just a one-off. It's likely, one of these settling earthquakes, right? We've described before how the island kind of has the area of active volcanism really dominant over here beneath Mauna Loa and Loihi and Kīlauea, and this is the hottest area. The whole island is moving like a conveyor belt over top of the zone, so it kind of gets hot and expands over here, and after it moves away, it starts cooling, contracting, and kind of dipping back into the ocean. So there's lots of adjustments. It's almost like a seesaw. The north end kind of tips down into the, wants to sink that back into the ocean, while this south end is being buoyed upwards by the heat of the magma itself. So you actually expect lots of earthquakes in the northwest area of the island, overall, just by just that kind of settling effect. So, when I just see one earthquake here or there, whether it's one over here or whether it's one over here, or the Kīlauea, almost more than 10 years ago, those are all kind of more or less in that same pattern. And what's interesting is that because these volcanoes are older and more solid on the inside, they actually ring more like a bell when you have an earthquake, right? So when an earthquake happens in that area, more people feel it, right? And so it seems more widespread, and it's something that everyone talks about for sure. Maybe less frequent than if you're living in volcanoes. Like, what happened with the earthquake today? Oh, another one, whatever, right? As opposed to if you're up in Kohala, maybe that's not, not how you would respond, So it's definitely interesting, for a seismologist, you can go into the detail of that and exactly how and where the fault was and how it might have moved and all that. But for our purposes, I think it's just good enough to say that it was a settling earthquake and it's nothing to do with any kind of eruption, nothing to worry about as far as that. Our typical pattern is kind of still in play. We have our summit earthquakes, we're in Halemaumau, and we have our deep Pahala earthquakes down over here, right? So that's the same pattern as before, and without kind of going into that same detail again, we'll just kind of leave it as that's unchanged in this pattern. You guys want to add anything to the earthquake report?
No, let's talk about the Indonesian earthquake, though, while we're here.
Yes.
People heard about that today.
Yes, okay.
So, well, I don't know much about it other than there's a big quake. I think it was a 7.7 by the island of Sulawesi in Indonesia. It's a really odd-shaped island with a lot of rare wildlife and plants on it, very jungly place. And that whole region is, of course, at risk for tsunamis. So we have scattered reports of some real significant waves, maybe 2 or 3 meters, that came ashore apparently around Sulawesi. Didn't see much confirmed information through the day, but and Philip and I didn't notice any teleseism on our earthquake feeds here in Hawaii. It didn't seem to register on our instruments, and a lot of times those really powerful quakes will leave a signature on the seismographs way out here, but didn't really notice today. Did you find any evidence?
No, I didn't actually look at the actual seismograph to look at the actual signal, the scribbles. So maybe there was something there, but whatever it was not big enough that we detected it easily, visually on 2 meters at least, which is kind of when we have the really big ones. So it might have been there, but it might have been too subtle for us to actually visually catch. So I did pull up the page here to show you guys this Indonesian earthquake. So this is the island of Sulawesi in Indonesia, and we'll zoom out in a second, but you guys can see that the 7.5 earthquake was this one right here. Depth of 10 kilometers. So it's not exactly super shallow, but shallow enough that that's going to really cause a lot of shaking, and obviously it caused a big tsunami, which was the I think Ryan posted an article on Tracker earlier today with some videos of the tsunami, which is really devastating and kind of hard to watch. There's basically in a video. You see the video, John? A big billboard.
Terrifying.
And you see the whole village, and in a village you actually can see before the wave comes in. There was a wave that came in before that. Everything is really kind of destroyed and wet and all soaked, and they're all up in a tower, and the wave comes in. It's as high as a billboard. Yeah, and just covers everything. So fortunately, that particular video was taken. So the first wave is what would worry me, right? Because normally with a tsunami, the closer you are to the epicenter, the less warning and the more immediate the tsunami actually is. So quite likely, because that video was taken very near that epicenter, it was probably a bam bam thing, right? The earthquake hits 7.5 according to the USGS page I'm on right now. It may have been revised and may not be updated here. But that means there's going to be heavy infrastructure damage, right? So you're basically running out of your house because it's collapsing, and suddenly here comes the ocean, like that quick. So that was the most dangerous part. By the time the video was taken, everyone was kind of sheltered up in the tower, but who knows what they had actually seen up to that point, what kind of trauma they had gone through to get there, and what they're going to deal with coming down from there, right? Because imagine, it's not that different from, seeing your own neighborhood being destroyed by lava, but you see it all destroyed by a giant wave, in
really
seconds.
Quick, too, instantly. And you mentioned something interesting this morning. I saw that just in our chat group that in that area people are accustomed to the threat of tsunami, and so when they feel large quakes, a lot of people know, just socially it's customary to know to get away from the water, and hopefully that saved people in this event. And that's something to remember in Hawaii. We have the warning system. If a tsunami is coming all the way across the ocean, then we get a lot of warning if it all goes well. If we make our own tsunami from an earthquake in Hawaii, you just have to know, if you're by the water and you feel a quake, get away from the water. That's the one thing to know. Yeah. So everybody in Hawaii, we have it easy. We can always get above the water. There's always a slope. You only need to 30 feet uphill, but people just need to know that if you feel a strong quake and you're by the shore, get away from the water and wait and see. You might only have a few minutes. So
so you don't want to be super careful. Anything you feel at the ocean, definitely use it as a warning sign. I was taught a measure of how strong it is how much trouble you have standing.
Yeah.
So if it's a strong enough earthquake where you actually start having trouble standing, losing your balance, that's guaranteed a tsunami generator.
Yeah.
The other ones, maybe not, play it safe. But when you feel that, turn and go inland. And, I haven't been to the Pacific Tsunami Museum in Hilo for a while, but it's a fascinating place. I recommend everyone go and learn about tsunamis there because Hilo's got a very rich history of tsunami. But one interesting thing that I learned there when I was there, I don't know how many years ago now, I think I've said this in the previous live as well, is the slopes in Hilo are steep enough that most tsunami waves don't make it more than 2 blocks inland.
Cool.
So that gives you guys a finish line to run for.
2 blocks,
right?
And you've made it.
Doesn't mean you have to stop. You can keep going.
Yeah.
You can keep going. You know, you actually, you know, and normally the thing with tsunami waves is there's a period between them of something like 15 minutes, right? So when a first one hits, like, you know, start going in, right? But, you know, just because the first wave passes, it doesn't mean, oh, and nothing's happened for 10 minutes. It doesn't mean go back. You got to wait, you know, longer than that, right? I kind of, the analogy I've always used is like a log falling into a swimming pool, right? And the water is going to slosh for a while. It's not just one big splash. There's one big splash to start, for sure. And you might get a second big splash, and a third one, but the fourth one might not be as big, and the fifth one might not be as big, and the sixth one might be a big one again, right? That's the kind of dynamic that you got to deal with. You basically got to back off and wait till everything kind of calms down, you know. So, but really, that first moment is the decision, is the one where you got to take the action, right? And you know, the other
2 blocks, Hilo people. 2 blocks to run. Just remember that. It's not that far.
Yeah, and you know, fortunately, Hilo doesn't have basements, right? So we have to deal with that, you know.
We're overdue, so it's always good to remember.
Yeah, very much so. Yeah, very much so. And you know, my family lived in Thailand during the Banda Aceh earthquake. You know, and you know, one of the big problems in Thailand was people were trapped in supermarkets in basements, right? So that was a big issue in areas like that. You know, and you know, the other warning sign is, you know, if you ever see the ocean receding, right, and there's fish flopping around like in what used to be the ocean, now it's dry land. You don't go run out and catch the fish, right? Go the other way, right? Because those fish are going to be coming to you via a giant wave, right?
Right. Oh, but people, the wave doesn't always go out first. Sometimes the ocean doesn't recede much. It depends on the dynamic of the wave. So I've heard some people say, oh, you know, when the sea goes away. That doesn't always happen. If it's happening, definitely get away from the water.
Yeah.
But that's the other thing. Sometimes the tsunami will just come ashore without receding first. So you just got to know these things. This visit to the Tsunami Museum can help.
So the earthquake is really the number one trigger, right? If you're out and, you know, like within 2 blocks of the ocean, you feel that big earthquake, right? If you have any doubt, move in, you know, and check your alerts or whatever, you know. I mean,
and think about how strong that is. If you literally can't stand, you're in the 7 point something if you can't stand up on your own. So that should tell you it needs to be a powerful quake, but you just got to practice the awareness about those things.
Usually it's about magnitude 6 or so. Roughly speaking, you know. I mean, roughly speaking. If you have like a very shallow local one that's smaller than that, it could cause, you know, but you would probably feel a similar ground shaking effect. Even from a smaller one, you know, that kind of area. So that's the word, you guys. Stay safe from tsunami. You know, our thoughts are definitely with everyone in Indonesia. You know, we know that we've dealt with that before, and hopefully they're dealing with it well. You know, some people just probably didn't have a chance. Unfortunately, that's kind of what makes us so sad.
So many people over there, crowded places.
Yeah, but they do have a long history of that, right? You know, and it's interesting that, you know, part of the story that came out today, which is probably the most shocking part of all, was a government response, right? And you know, not to draw any kind of parallels or anything, but you know, I mean, you know, the people there, you know, have dealt with this without government warnings before. The government is trying to step up their game and put in place these warning systems. Clearly that did not work today because there was a warning retracted, right? And that should never happen, right? You'd rather the thing expire on its own rather than get retracted prematurely. Hard lesson to learn.
That's a wild story. I want to hear more about that. What happened? Crazy.
But, you know, if you guys are by the ocean here, right, don't wait for the sirens. Don't wait for the government to sound a siren. Don't wait for a helicopter with a bullhorn to come around. Take action on your own like everyone else has to do, right? So, and that's, you know, maybe a theme that we've dealt with, right? You know, deal with the lava on our own, or deal with the hurricanes or the floods or what have you. You know, we're as a community learning that the community takes care of each other and not the government taking care of you, right? So
don't ignore the signs. Keep safe.
So anything to add, Dane, or nope. It's all good? Yeah. So all right, Indo, we're thinking about you guys, and let's see what we can turn to next.
Yeah, I saw that. Pretty crazy.
So let me zoom out of here so you guys can get an idea of where this is. And so the island of Sulawesi is right here, right? And this is the Indonesia crescent-shaped archipelago right there, right? So that's the earthquake right there, tsunami generating in Indonesia. So let's turn now to our tilt, back here to Hawaii.
Hooray, tilt.
And more stuff to talk about. So here is the USGS page, which is showing just the last 2 days at the summit and at Pu'u'o. The summit's showing mostly flat, some little wiggles, but nothing significant. You guys can look at the scale here on the side.
Very small.
Right, very small. Each stippled line is half a microradian, so that's really too small to say much about. On the Pu'u'o plot, we are seeing a trend upwards, but in the last 2 days, we're going from minus 0.5 to plus 0.5, so that's about 1. And within that, so, these might have been little earthquakes that happened, and it's hard to say, what's causing this 1 microradian increase, but it could be magma, it could be something else. I'll just leave my side at that. John, you want to jump in here?
Oh, I guess I can at this point. Yeah, I mean, that's the thing. The Pu'u'o tilt signal is one of the strongest signals we have in the East Rifts. It's come up over a couple weeks, a little more than 2 weeks. It's actually amounted to about 6 microradians. But you see it's happening really slowly, and so it's definitely the signal to watch, because that's kind of significant in the magnitude. But remember, the tilt is giving us a relative value, and so it works best over the short time periods. And so even though it's getting to be about 6 microradians, that's definitely something. It's not happening very fast, so it's still a little unsure if we can definitely call that magma. But that's the trend to watch, and it's also peculiar that Pu'u'o started inflating and continued inflating independently of the summit. So that's a unique situation we haven't seen very often. But it's still at the point of like, we're watching this, and just remember it's giving us a relative value, not an absolute amount of like ground motion or absolute tilt. It's relative over time, so just got to kind of keep those things in mind. But that's definitely one of the stronger signals that's showing the inflation in the East Rift.
So I'll counter that a little bit with that all these signals.
Hold on, I gotta get you on the screen here.
All right. So I'll counter that a little bit. All these signals, they're so small that I don't trust them. The general trend is there. It may be important to watch a little bit, but I don't see anything. That's the thing. It all looks flat to me. There's such little changes that if it were to show a sign of reactivating, it would be obvious. Right now, it's just so flat across everything that we're bouncing around looking between noise, that it feels like. Pu'u'o probably has the strongest chance to break that barrier of being, distinguishable from noise, but I still have a hard time believing that little amount of microradian change over that amount of time is significant.
6?
Over 2 weeks? Yeah, I still think that's pretty on the small side, and I want to see more than that to say that something's happening. Right now, that shows that it's pretty much nothing's changing. It's more similar than it is different.
It's definitely changing. The question is what's causing it. So that's where I would see the debate is focused. Like, that is definitely change, and it's definitely starting to be significant. But is it caused by magma is still the uncertain thing. So that's how I would break that down, because we're definitely seeing changes. They're just still really small.
Right. The challenge is that we don't have documented all the range of things that can cause small tilt changes, right? So that's where it's really uncertainty comes from. That's why I say, well, if it's below the 5, it could be magma, it could not be magma, it could be a bunch of other things. But if it's above that, then you start getting to the point where what else could it be besides magma? And that's the range where I have confidence using that as a tool for predicting something. So what we're seeing, I've been telling John, may well be the signs of something changing that will lead to a prediction in the future. But I'm not comfortable at all using that data to make any inference about anything until it actually changes at a faster rate, right?
In hindsight, if something does happen, we can look back and say, oh yeah, look here, it was starting, we could start to see the pattern at this point. But trying to predict off of that is a different game entirely.
Absolutely, yeah. So I mean, that's the whole point here, is we're trying to find some utility in information, the little information that we do have, and trying to say, can we actually use this for some forecasting, right? You know, and that, you know, that's the really challenging part, right? Is, you know, we don't want, you know, I mean, John's taking the approach of let's try to squeeze every information out of this as we can, because it may be too late when we see the signal that's big enough. Yeah. And I'm saying, well, if I don't see a signal that's big enough, it doesn't matter. And it's like, well, if it does matter, because you might have had a chance to see it coming. So you're absolutely right on that.
I'm just trying to find the magma.
Yeah.
I think these are signs.
Yeah. I'd rather not find it. You know,
well, it's not like I want to find it, but that was the mission.
I'm just giving you a hard time. Yeah, I know. We know.
It's my job.
Yeah. That's what we're watching. Yeah. Oh, I got some lightning in the background.
Yeah, that was pretty bright.
Oh, cool.
I
couldn't tell what that was. I was looking
around the thunder, though.
Well, Harry Durgan said we could have some thunder building up in the afternoon. By Sunday, it's supposed to get nicer.
The weather guys know what they're talking about.
Yep, sometimes. Yep.
Yeah, so let's turn back to the toplot, you know, and like, you know, with all that said, you know, we can look at like the past month. Actually, you know, one more thing is that there was a Volcano Watch article published today. That
really good article.
HVO writes those articles every week on Friday. They come out in the Tribune, I believe, on Saturdays, or is it Sundays? Sundays, I believe, they actually get published in the paper. Sure. But online, they're available on Fridays, so you guys can find that. I believe it's actually posted on Tracker, I believe, that article, yeah. So check out that article. It talks in detail like, about the things we've been discussing. It's all written down. It kind of talks about, you know, the issues with tote meters, you know, like when you can trust them, when you want to be more careful, you know, when to use GPS instead, like, you know, what physical processes are actually happening, like the actual instrument being down of an 8-foot hole whose walls are settling and pushing on an instrument in ways that are not predictable, like that kind of stuff, right? So, I mean, check that out, you guys, and, you know, you guys might, you know, those of you guys who are nerdy about this tote meter stuff, and, you know, you guys can look there as well.
One of the takeaways I had from the article, which might help anybody who's following along, is that the GPS tends to get, you have more confidence in GPS information over a longer time frame, over months to even years or more. GPS reveals a lot of things. The tilt is kind of at a different scale, and so it's more important in the short time frame, days or weeks or up to a month or so. The tilt is keeping track of those relative changes, and GPS is more of a different kind of time frame that you look at the data over time, you know. So those are two important things given what we're looking at here now. Yeah. So the tilt is kind of the short-term look at how things have changed. GPS gives us a different frame of reference for how things have changed in time.
That was an awesome segue for us to look at the GPS.
Ah, perfect.
So well done. It's as if you're a professional. Mm-hmm. So here is our GPS on the Hawaii Tracker page, and our Caldera stations are basically showing flat,
straight across,
flat with no noise. Here's our 1 year of Uwekahuna, right, showing the history of this whole past 4 months right here, or it's probably been. Seems like I'm losing track of time now, right? This is where we past 4 months now.
Yep.
So interesting to look at this in hindsight now, right? Our scale is going from almost, I don't know, 0.75, 3/4 of a meter above, to 1 3/4 below, right? So that's 2.5 meters of drop up on the rim of the caldera. Right, because we all know that the bottom actually dropped out 1,600 feet. So even up on the rim, you know, by the museum, that's how much the ground dropped, 2.5 meters.
Amazing. Very.
So in the context of that, we can kind of say that all these little changes are pretty insignificant, basically, right?
Yeah, in that context.
Yeah.
This is obviously a huge event. That's our historical event. The volcano can do all kinds of things that are smaller than that.
Yeah. Well, yeah. So this is the event, and this is not the event.
Yeah.
I mean, simplest way to put it.
Flat, yeah.
So if we're looking for another event, we're not there yet, right? So maybe that's the takeaway there. And
There's enough of a gap that we can say basically that something that happens will be another event. It's not directly, it didn't carry over. There was the break,
right,
and then something.
right. Yeah, that kind of comes to the, what I was saying before about how we just divide these eruptions and categorize them.
Right.
Some people are wanting to say that this eruption now is actually part of the Pu'u'o phase, and that's some ways of thinking about it. You could totally say that.
You can make that argument.
But then you could say that Pu'u'o followed from Mana'ulu, and Mana'ulu followed from Kanakakoi. I mean, you can kind of just how many of these are going to chain together potentially, right? So that's one approach. Yeah, it's all related. It certainly is. I've been saying that for a while. Most of the dynamics of the volcano in the last 30 years have been dominated by the 7.7 earthquake in 1975. Right, so that's an example of me saying that. How slowly.
One detail though is like Pu'u'o never really quit. It didn't go into repose when everything shifted. So that's one way where I could see people drawing the continuity from one eruption to the next, just because there wasn't a time where the volcano went silent in between the two events. But they're definitely very different chapters. There is a break between those two periods for
one
sure.
One event led to the other. The
one led
inflation,
to another.
Yeah, but once that threshold was crossed, it became a separate event to me, at least. It was
totally different.
And then it made that evident on the 18th of May when the fissure started opening back up the rift, working its way back to PGB and into Leilani, and it was a different eruption at that point too. It wasn't the old flow, it wasn't slow, it wasn't viscous, it was fast moving and scary at that point.
Totally, yeah. I mean, the fact, the summit got involved, to me makes it so unique. Now, I personally also feel to call it a different chapter, but if someone else wants to call it part of the Pu'u'o chapter,
yeah,
fine,
they can do it.
Fine. I mean, it is related, and if that's the division you want to not make, fine. They're definitely connected, and no problem with me.
Just the scope you decide to use on it, how you decide to look at the whole thing. That'll define how you classify it.
Right. So I mean, those definitions aren't as important maybe as as we're discussing, but that's it. So let me turn back to the GPS because there's one final important thing here, which is let's go down. So this is the Pu'u'o station, right? And we're looking at over here this section, basically showing flat. This is the east component, the north component is maybe the most important one, and that one's also basically flat. And the up component has more error, we believe, so this little wiggle is not detectable from flat either, right there. So looking at the Jonica flow, which is the one closer to Leilani here, we have not exactly the same pattern, but a consistent pattern, where since eruption it's been not flat, but in steady decline, right? Or what's this movement?
Moving back towards
movement to the west. In this, this is the east component.
Yeah, movement to the west.
Yeah, this one is showing movement. Well, it was moving to the south, and now it's moving to the north. And this little signal, even though it's kind of small on this plot because of this big data gap right here, based on the offset. Each one of these lines is 10 centimeters, right? So half of this, which is about what the range might be, is 5 centimeters or so. So that's actually a fairly big difference right there, even if it looks kind of small on our plot. So this is the important information that we have right here. This is similar to what we saw on the last county presentation by the USGS, the community meeting. They actually showed a plot of GPS, and this Jonica station was the only one that was in this pattern, and it seems like it's remaining so. So once again, we trust the north component more, the up component more error, so it may be showing the same trend, but maybe not. So in any case, we're having to keep a close eye on the Jonica GPS station as well to figure out what's going on. But one thing that's interesting is, is that we've been kind of discussing a little bit the dynamics of how a rift zone might settle as the eruption wanes, and it's hard to really say what exact pattern you would get. There's like a whole range of different motions that a block that's adjusting, settling down, and possibly tilting that it could take. that makes it really difficult for us to really say anything conclusive about what this means, right? We can say that we see the signal on the plot, but what does it mean? That's a lot harder to say what it actually means. So,
especially when it's so subtle.
Yeah, so we'll have to keep watching, and if we see, as usual, our at least my MO is going to be multiple lines of evidence for anything that we're going to decide is actually happening, right? So we're keeping an eye on the tilt, the GPS. Still want to hear about the gas, right? If gas is increasing in the area of the Jonica flow, then you might say, well, maybe that's got something to do with magma, but if it's not, maybe it's something else. And, we'll just keep going from there, right? Whether it's gas or seismicity or the GPS, or we have multiple lines of evidence, as usual, to convince ourselves that something different is happening.
And there are multiple lines of evidence that are correlating now, but they're just small magnitude. But like the GPS movement is pretty interesting to me, the way it jumped around. So like when the eruption began, first, if we were looking at this as the east component, first it moved towards the east, towards the rift, and then away from it, and now it's sinking back towards the rift again? Or did I describe that backwards?
I think it's the
opposite.
So the east, right? So you can say...
So it went...
Well, because west and east is not towards the rift at all, is it? It's along the rift.
Along the rift, yeah.
So let's just say west and east. So it goes up is east and down is west.
Yeah, so down is west.
Yeah.
And then, but in that location, that would be... but what I was trying to say is when you look at how these jumped, it made this big motion, and now that motion is kind of reversed again, and so when you add these up, that station is moving slightly away from the rift, and looks like it could be vertically rising, and so that's something to watch as well. But at the moment, these are all really small signals, but it is showing that station is expanding, moving away from the trend of the rift at this moment, and it had done the opposite during the eruption. So it's just interesting, and especially with this one, that one's vertical, so that one's directly related to inflation in the area. If that keeps coming up over time, then that might mean the area is actually inflating. So, but anyway, just trying to uncrack some of the GPS. I'm not sure if I did it very well.
Yeah. Oh, no, yeah, I think it's interesting. Yeah. We're getting drowned out by the noise here a little bit.
Mm-hmm.
So, but we're kind of getting toward the end of our update anyway. Yeah. So we'll just kind of start wrapping it up here. What else we got to show you guys? I showed you guys the webcam ready to start. So we kind of did that already, and we did GPS, we did the tilt, we did the earthquakes, we talked about the gas, we even talked about Indonesia, right? What else we got to talk about? Maybe just a little bit of social stuff. So we're here at the hub. The hub's still open on Mondays and Fridays. We wanted to share with everyone who's in the area that this coming Monday, there is going to be a community dinner after the hub hours, right? So the hub's open 2 to 6 on Monday, and starting at 6, from 6 to 8, there's going to be community dinner, potluck style, right? So bring what you like to eat, bring what you like to drink, bring stuff to share if you like. We're going to be kind of trying to recreate what we had before, like the last time we did this was 2 months ago at least, right? Where we actually had people sit down and serve food. We're not going to serve food, but there's going to be food to lay out on the tables, everyone sit down together, talk stories, share experiences, all that stuff, right? So that's kind of
forward to that.
Something anyone who's around, on Monday 6 to 8 p.m. All right,
also,
go ahead.
Slight change. We also got Bill Hansen. He's from Civil Defense. He's organizing a project Blaze a Trail to Pohiki. He's gonna go in from McKinsey side at 6 a.m. Sunday, and yeah, they're just gonna blaze that trail to Pohiki. So yeah, bring gloves. Gloves are important.
Yeah, and that is also posted online in Tracker, so you guys can check Tracker for all of these different references we're pointing out for you guys. Anything else? Anything else going on this weekend?
Still twinkle lights in the fissure. Still little twinkle lights in the background, but we're watching it. Oh,
so will-o-wisps,
fairies, fairy dust. Well, the reason I pointed out it is because for any incandescence, there needs to be heat flow. So whatever's causing those lights, there's still heat flow in there. So keep an eye on it.
Yeah, that's a whole can of worms, right? Because heat flow exists everywhere on the Earth. right? Every surface of the Earth has heat flow, so it's
But what I mean is
increase in
that
heat flow.
it has to be continuously heating that to create the incandescence. So churning, circulation of lava there has to keep happening. So we see that diminishing.
I gotta disagree with you there, because
For something to keep glowing, it needs to be heated.
it has to be heated, but
Yeah.
the amount of heat in the Earth is essentially infinite to
Yeah,
us. from
but
the
we don't
surface.
have little glowing holes everywhere.
We don't, so it's clear that there's a crack there. But
Right.
the fact that the fact that it's a crack maybe is more important than the supposition of circulating magma. I believe there is magma down there, keeping it hot, and it's clearly there's extra heat flow because of that. But I wouldn't jump to the circulation personally. So that's just where I disagree.
In order to see that light from a glowing crack, if it is a glowing crack that's like red hot to produce that signature on there, there would need to be continuous heat flow through that crack to keep it that
Heat flow out of the crack,
yeah.
but the heat exists in the Earth regardless of magma being liquid.
Okay.
Right,
But how long would it stay glowing if there wasn't some sort of circulation to keep allowing that heat through? Okay. The lava can't be far away, right?
No, it's not, the lava's right there. No debate about that, right? I just don't think it's circulating. I think it's parked.
Wouldn't you see the glow diminish? It would get a crust over it and stop glowing over time?
Or it could be the gas, how the gas pushes its way out of the crack, right? Because, it's not a constant, steady state flow of gas. You're going to have some turbulent flow of gas and build up pressure. You're going to have like bigger bubbles, let's call them, and then smaller bubbles kind of thing. And,
Yeah.
it's going to change the shape of the crack. It's going to, had a little mini tilt meter on the edge of that crack. You'd see it doing the same thing the rift zone does, like widening.
But for the gas to be coming out hot enough to heat that and keep it glowing, it just seems like you would have to have some circulation in the lava. Like a hot rock surface there wouldn't stay glowing red hot unless there was circulation in the lava.
There's circulation of heat. Is about what I would say, right? Which comes from the lava, but the lava itself doesn't have to move.
But it just wouldn't stay glowing, right?
Okay,
Because
well-
it crusts over.
It can, because it's all about how much heat comes out of there.
For how long, though?
Right, so let's think
That's
about
what I'm
how
wondering.
when the gas was coming out above the, before the overlook vent opened at Mau Mau, right? That rock was glowing just from gas flow coming out of there. That it was fed, the heat was fed from the lava, but it was just heating the gas. The gas was coming out. The gas was glowing the rock, and
a
the
day
rock,
or two before the lava came
and the
out.
rock, and the rock was glowing. Yeah, so it's, it doesn't exactly, it's not a perfect analogy because lava came up after that, right? But
So it was being heated.
but it wasn't the lava that was, the lava was doing the heating, but it was the gas that was coming out. It was just hot gas. It was
But
causing
the
those
only
rocks
way
to
the
glow.
gas could be that hot was with fresh lava to feed
Yes,
that heat
but does it have to be
create the
circulating? Is my point. Why does it have to be circulating? If it's moving in there, then
It just seems that if it wasn't circulating, it would freeze over and you'd stop seeing glow. That's
I think so long as heat is able to escape out of there, right, then you can keep going for a long time.
The thing to note here is they're not talking about glow you can actually see with your eyes, or that's yet to be determined.
Yeah.
It's pretty unlikely, in my opinion, that you can actually see this glow. It only appears via infrared at night. That's it. Otherwise, I bet it's just dark out there if you were to walk out and look at it with your own eyes.
Yeah.
So we're talking about like less than visible light. That's significant in and of itself, just to know that we're still dealing with really small scales when we're talking about even the glow. It's such little glow, it's debatable if it's even visible.
But it's there.
But it's there.
It's definitely there.
It's definitely
It would be
hot.
interesting to see if you could see it with your naked eye.
All right, that's my question.
Yeah, so we're gonna figure that out, and we'll report back to you guys in a while about that. But for now, we will have to just wonder.
Wait and see still.
Yeah, but one thing to kind of just gonna point out is that area is gonna stay hot for a long time. It's gonna be degassing for a long time. So you guys smell more gas this next week, and you feel the heat from the changing winds. Like that's not a reason for alarm in and of itself. So we'll keep watching all the signals, and we'll report back to you guys if anything changes in the meantime. Otherwise, we'll probably get back to you guys on Monday when we're back here at the hub.
Sounds good.
And give you guys an update of what happened over the weekend. So, anything you guys want to add here at the end?
Nope.
So,
All right, aloha.
from Dane
All right.
and John and myself,
Aloha.
aloha.
Stay classy,
Stay classy,
Puna.
Puna.